In this video, I'm going to talk about how to graph compound inequalities. Looking at this first example, we can see it's an AND inequality, which means that when we graph, we're going to have an overlap of two different inequalities. So let's kind of see what that's going to look like. If I sketch out a graph here, I'm going to put -8 over here, maybe 0 right here, and 4 over here. The first thing that I'm going to do is I'm going to graph both of these inequalities, and I'm going to show you what happens. I'm going to graph them separately. X is greater than or equal to -8, so that is a closed circle, and I'm going to shade to the right. So we'll give that a good shading there. X is less than 4, so that's going to be an open circle and shade to the left. And so with AND inequalities, what happens is the actual graph, the solution, is the overlap of these two guys right here. Where do those inequalities overlap? And so here, they overlap between -8 and +4. So when we actually graph the solution to this compound inequality, we still have that closed dot at -8 and that open dot at +4, but we're only shading in the middle because that's the overlap of those two separate inequalities. So the solution, the graph to the compound inequality, is this right here, the shading in between, because that's where the individual inequalities overlap. Those are those x values that satisfy both of those inequalities at the same time. You may also see an AND inequality that looks like this, which I like to kind of say it's sandwiched into one inequality, but there's two inequality symbols and the x is in the middle. So if you want to graph one of these, I'm going to label very briefly my -2, 0, and 6. Because these are both less than symbols, we're going to have open dots at -2 and +6. If this was a less than or equal to symbol, we would have a closed dot at -2. But in this case, it's just a less than symbol, so we'll have an open dot. And then same with 6. We're going to have just an open dot there. And notice how the x is in between -2 and +6. We need an x value that goes in between those two numbers. And just like we graphed before, we're going to shade in between those two numbers. So it's any x value in between -2 and +6. The last one is an OR inequality. So if we have an OR inequality, we're going to go ahead when we graph that. And again, I'm gonna plot my 0 over here and 3 over here. Both of these are going to have open dots because they are either less than or greater than symbols. So we have an open dot at 0, open dot at 3. And where are we going to shade? Well, really what we're doing is we're graphing these individually. So y is less than 0. We're going to have an open dot at 0 and shade to the left. And for y is greater than 3, we have an open dot at 3, and we're going to shade to the right. So it's really just two separate inequalities graphed on the same number line. They're always going to point away from each other with OR inequalities. So similar to the AND inequality where we have two inequalities on the same graph, it just looks a little bit different. So to kind of recap here, the AND inequality, you graph your dots the same way, either open or closed, depending on the symbol. And you always shade in between the two dots, where with the OR inequalities, the dots, again, we graph those the same way depending on our symbol, but we're always going to shade away from the two numbers. So we're not going to shade in between, we're going to shade to the left and to the right with the OR inequalities.